Assalamu alaikum wa rahmatullahi wa barakatuh. How are you, my dear students? Today, inshallah, we're going to finish the functions, the last part of the functions on chapter 2. We're going to talk about even and odd functions and the modulus function. Let's start with the even and odd functions. We have two types of functions. The first one, which is even function, and it's represented as f of x is equal to f of negative x, which means if you replace any negative value on the function, you'll get exactly the same value when you replace the positive value for all the values of the x. All even functions are symmetrical about the y-axis. When you sketch the curves of the even functions, you will get a symmetry line, which is the y-axis. For example, x squared, the quadratic, the parabola quadratic function, is an even function. When you replace a positive value, you'll get exactly the same value when you replace the negative. So, for example, if you replace negative 2 squared, you'll get positive 4. And when you replace positive 2, you'll get 4 as well. So we call that even function. And as you see, the graph of the y equals x squared, which is the parabola, which we called it parabola, is symmetrical about the y-axis. So we call the y-axis here as symmetry line. X power 4 as well is symmetrical about the y-axis, and it's called even function. Cosine, one more example of the even function is cosine x, the trigonometric function curve cosine x. So it's symmetrical about the y-axis. As you see, this spot is the same as this spot. The second type of the functions, which is the odd function. The first point here, if f of x is equal to negative f of negative x for all the values of x, so we call that function as an odd function. So positive, when you replace a positive value, you're supposed to get a positive, and when you replace the negative, you're supposed to get a negative value. If you want to make them equal, you have to add a negative sign to the negative value when you replace it. I'll show you that later. The second difference between the odd and even, all the odd functions are symmetrical about the origin point. So in even, they are symmetrical about the y-axis, but here they are symmetrical about the origin point. Examples, we have x, x cubed, and sine x. For example, x, if you replace the x as positive value, you're supposed to get a positive. So replace x as 2. F of 2 is equal to 2. But when you replace negative 2, you have to get negative 2. If you want to make them equal, so f of 2 is equal to negative of f of negative 2. So negative of negative 2 will give you a positive value. This will happen only on the odd functions. But in the even, positive and negative, both are going to give you the same value. So straight line is one of the types of the odd functions. X cubed, the cubic function, is one of the types of the odd function. So as you see, the symmetry line, or the curve is symmetrical about the origin point. It's not the y-axis like the even function. And sine x curve, it's one of the trigonometric function. And by the way, tan x as well is one of the odd functions, because it's reflected about the origin point, not about the y-axis. The modulus function. The modulus function is represented in the form of these two lines. We call it modulus or absolute, or we call it magnitude of x. So that we call it modulus function, ignoring the sign. So modulus of negative 6 is equal to positive 6, and modulus of positive will give you positive value. So the definition of the function in general is modulus of x, x positive x and negative x, and that will happen when the x for all the values of x more than 0, which means all the positive values including the 0, and negative x for all the values less than 0, which means for the negative values. We have an important note here. Modulus, if the modulus A is equal to modulus B, and you square both sides, so they're supposed to be equal. A is equal to a squared, and positive b squared is positive b squared, so they will be equal. If you square the negative signs on the both sides, you have to get a positive value, and still they are equal. So note that x, modulus of x, in case of modulus of x less than a, so we have to write a range starting from negative a to a. And for the modulus x more than a, we're supposed to write a range for the values less than negative a and the values more than positive a. So we're going to use that on using or solving the inequalities. Here are some examples from the textbook, exercise 2D, page 35. Question number 1, solve these inequalities and illustrate the solution on a number line. I'm going to show you now modulus of x less than 2. So remember the note that we talked about it before. Modulus of x less than a, so the range is from negative a to positive a, which means here the range is from negative 2 to positive 2. How are we going to show that on the number line? This is the negative 2. We're supposed to start with the 2 first, negative 2 first, because negative 2 is less than 2. So unshaded dot, and you have to join them because you're talking about the values or the values between negative 2 and 2. But negative 2 and 2 are not including on that range. Modulus of x more than or equal to 3. So remember, the note is, or the condition is, less than positive or more than positive, less than negative or more than positive. So we're supposed to write here x less than or equal to negative 3 or x more than or equal to positive 3. How are we going to show that on the number line? Negative 3 and 3, shaded part, but it goes to left because it's less than negative 3, and shaded part for 3 and goes to the right, and you have to shade the part which is more than 3. Now, modulus of x less than 1, x minus 1, modulus of x minus 1 less than 5. So we're going to represent that as two parts as we did before. So you just write x minus 1 between negative 5 and 5. Move negative 1 to the both sides. So negative 5 plus 1 less than x less than 5 plus 1. It's negative 4 less than x less than 6. On the number line, negative 4 first and then 6, unshaded for both of them, and then you have to join the line to represent the region between negative 4 and 6. Here is another example in exercise 2E, page 37 on the textbook. Solve these inequalities. Modulus of 2x minus 1 more than or equal to 5. So remember, into this case, it's more than a. More than a is less than negative or more than the positive. But we have to use less than or equal for all of them. Why? Because you have more than or equal here. So by moving negative 1 to the other side, we'll get negative 5. So first of all, you just equate 2x minus 1 to negative 5, and then 2x minus 1 to the positive 5. Less than negative and more than positive. Moving negative 1 to the other side, negative 5 plus 1 is negative 4, and then dividing both sides by 2, x less than or equal to negative 2. And then by moving negative 1 to the other side, 5 plus 1 is 6, and by dividing both sides by 2, x is more than or equal to 3. Because the having equal, so you have to shade the dots, and you have to present it on the number line like this. Same idea into this case. In case of less than, modulus of x less than a, so x between negative a and a. So we have to use this condition here. So 6x minus 5, negative 7 at the left and positive 7 at the right. Move negative 5 to the both sides. Negative 7 plus 5 less than 6x less than 7 plus 5. Negative 2 less than 6x less than 12. By dividing the whole inequality by 6, it's negative 1 over 3 less than x, because 6 divided 6 is equal to 1, less than 2. And this is the range. If you want to illustrate that on the number line, you start with the negative 3, negative 1 over 3 first, and then 2, positive 2, unshaded, and then join the region or the line between the two values, but without shading the 2 points because they are not including in the range. Into this case, we have to use squaring of both sides. We have to solve it as a normal equation. How are we going to do that? 2x plus 1 squared equals to 1 minus 4x squared. This is perfect squared expansion. So it's 4x squared, first by second by 2, which is 4x, and 1 squared is 1. By squaring the 1, it's 1. First by second by 2 is negative 8x, and then squaring of 4x squared, or negative 4x squared, is 16x squared. First of all, 1 will cancel the 1, because if you combine them into one side, you will have it with the different signs. 1 minus 1 is 0. By moving 4x squared to the left side, and 4x to the right side as well, so 16x squared minus 4x squared minus 8x minus 4x equals to 0. It's 12x squared minus 8 minus 4. Negative 8 minus 4 is 12x equals to 0. Now we have to take 12x as a common factor. Then you have x minus 1 left. Any x outside, whatever the power and whatever the coefficient, directly is equal to 0. Why? When you do 12x equals to 0 and x minus 1 equals to 0. So that directly x is equal to 0 and x is equal to 1. Now in case of less than, we're supposed to use the note of between, x between negative a and a, or less than or equal, because we have equal here. So the answer directly is x between 0 and 1. I know there is no negative or positive values, but negative a is representing the least value and a is representing the highest value. So the least value is 0 and the highest value is 1. If you want to show that in the number line 0 and 1, shaded both, you have to shade both shaded region between 0. How to solve equations involving modulus? You'll find this question, exercise 2e from the textbook, page 37. Modulus of 1 minus 2x is equal to 3. So you can do it by two ways. You can square both sides and then finding the value of the x, or you can equate each part to one's positive and one's to negative value. I'll do the first ways. I'll do the both ways. Way 1, by squaring both sides. It's 1 minus, first by second by 2, 4x, plus 4x squared is equal to 9. You suppose to move the 9 to the left side and rearrange the equation, minus 4x, then 1 minus 9 is negative 8. You can divide the whole equation by 4, then you have x squared minus 1x minus 2 equals to 0. If you divide 4 by 4 is 1, negative 4 by 4 is negative 1, and negative 8 divided 4 is negative 2. Two numbers give you the product 2 and difference 1. X and x, 2 and 1, negative 2 plus 1. You'll find two values of x. X is equal to 2 and x is equal to negative 1. These are the values. Second way, way 2. So 1 minus 2x once is equal to positive 3, and once 1 minus 2x equals to negative 3. So by moving 1 to the right side, negative 2x equals to 2, and then x is equal to negative 1. If you divide both sides by negative 2, by moving 1 to the other side, negative 2x is equal to negative 4, then x is equal to 2. Here is another example. We're going to square both sides if you decide to use the first way. So way 1, x plus 3 squared is equal to 2x all squared. X squared plus first by second by 2, which is 6x plus 9 equals to 4x squared. We can take 4x squared to the left side. Then you'll have negative 3x squared plus 6x plus 9 equals to 0. By dividing the whole equation by negative 3, then it's x squared minus 2x minus 3 equals to 0. Negative 3 divided negative 3 is positive 1, 6 divided negative 3 is negative 2, and 9 divided negative 3 is negative 3. Two numbers give you the product 3 and difference 2. So 3 and 1. What about the signs? 3 will take the negative and 1 will take the positive. So once x is equal to 3 and once x is equal to negative 1. If you decide to use that using way 2, so x plus 3 once is equal to 2x and x plus 3 is equal to negative 2x. Bring 2x to the left side and move 3 to the right side. X minus 2x is negative x equals to negative 3. Negative cancel negative and x is equal to 3. We got the first value. Do the same thing here. So x minus or x plus 2x is 3x equals to negative 3. By dividing both sides by 3, x is equal to negative 1. Last part of this chapter, sketching the modulus function curve. As you see, y equals to x is a straight line which just passes through the origin point, and it has two parts. Y equals or negative y equals to negative x. Into this quadrant, you know we have negative values. Positive, this is negative, negative x. Each negative x will give you a negative value of y. And on this part, all the values here are positive. So positive value of x, each positive x value will give you a positive value of y. So this is the straight line y equals to x. What will happen to the straight line? The negative part will be reflected about the x-axis, and then we will have the modulus of x. This is y equals to negative x. Because I told you y equals to x has two parts, positive x and negative x. X when the x is more than or equals to 0, and here when the x is less than 0. For the negative, it's negative x, and for the positive and the 0 as well, we have to use the positive x. Now let's sketch this curve simply using the rules of transformations. Modulus of x plus 1 is moved to the left 1 unit. So you have to move the curve 1 unit to the left. Or we can do one thing, just find the y-intercept first using x is equal to 0. So y equals to 0. Modulus of 0 plus 1 is equal to 1. So the intersection point on the y-axis is 1. Then finding x-intercept, so using y equals to 0. Modulus of x plus 1 equals to 0 by squaring both sides. So x plus 1 squared equals to 0. So by taking the square root, x is equal to negative 1. This is the curve. This is the y equals modulus of x plus 1. It's translated 1 unit to the left because it's positive. When it's negative 1, you have to move the curve to the right 1 unit. So it's supposed to be here. If you have y equals to modulus of x plus 1, so this is translation upwards, so it has to be here. So you have to move the curve of modulus of x 1 unit up. Last question, sketch the graph of y equals modulus of 2x minus 2. So using the same idea, we're going to find y-intercept first. So use x equals to 0, y equals to modulus of 2 by 0, minus 2. Any number multiplying 0 is 0, so it's modulus of negative 2, choose positive 2. So we have y-intercept is 2. Finding x-intercept, so we're supposed to use y equals to 0. So 0 equals to modulus of 2x minus 2 all squared for both sides. So 0 equals 2x minus 2 squared. By taking the square root, 2x minus 2 is equal to 0, which means x is equal to 1. So it's 1 here. Then you have to draw the line, and this is the curve. Y equals to modulus of 2x minus 2. If you want to talk about the types of transformations here, we have a stretch about the y-axis, parallel to the y-axis, and this is a translation downwards. This is not translation downwards, it's translation to the right, 2 units to the right. So with the stretch parallel to the y-axis, and then you have to move this curve 2 units to the right. And remember, this is not, it's not outside, it's inside. So this is translation, this is stretch parallel to the x-axis with a scale factor of half. So that's why we don't have the intersection point as 1 here. So simply you just replace y, finding y-intercept, and you find the x-intercept. Thank you.